In this video, we're going to start our discussion of arrays. So arrays are pretty important, and we're going to get further into some of the things that make C++ such a powerful language. So the difference between C++ and most other languages is that C++ allows for direct memory access. So that is something we've seen a little bit in the past by reference. We've talked about it before. We've done some diagrams. We're going to eventually talk about pointers, which it's a topic that a lot of new programmers have trouble with. So we're going to try to ease up on it a little bit. But this power comes at a cost. And the cost is it makes programs that are relatively dangerous and that can cause some issues. You can, for example, one program can overwrite another program running on the same system. So we have to be careful when dealing with these memory constructs. Okay. So an array is just a data type. Okay. So there are three basic types of data types the book talks about in chapter 2. We have simple data types, which are just things that can hold one value. That's going to be an int, going to be a float, going to be a Boolean, whatever. Okay. And then we have structured data types, which we're going to talk about some in this chapter, in the next couple of chapters, probably. In this class, basically, we'll talk about structured. And those allow for multiple items to be stored as one unit. Okay. And then finally, the pointer data structures are primarily the topic of data structures, the next course that you'll take. Okay. So the arrays, again, are the structured type. So most all of you, I think all but one of you, have had Python. So in Python, we have lists and lists and tuples. And lists are similar to arrays. Okay. So that's if you think about lists, that'll get you on the path. But there are some pretty key differences, okay, that we'll hit first before we hit arrays. So the biggest difference is that in C++, arrays have to all be the same data type. Okay, so you can have an array of integers or an array of floats or an array of anything. Even custom designed things like our enumerations, you can have arrays of those too. Okay. Where in Python, a list can contain anything, multiple things. Okay. The other big difference with arrays is that they don't know how long they are. So we don't get an out of bounds error that's reported back to us. The array index out of bounds error that you get in Python, because it knows how long they are, not how it works at all in C++. So we'll talk about that as we go along. Okay. So I've got some really poorly typed word there. Okay. And why is there a random LTN? Don't know. So anyway, it so happens that integers, we use our example, the int type, on most systems take up 4 bytes. Okay. A byte is 8 bits. So we have 24 bits of data that we can use. For an integer, there are long ints that take more and short ints that take less. But if we assume that our system is a 4 byte, I assume ours is, I don't know, we could check, but it doesn't really matter for our discussion. Okay. So the reason that that's important is that it explains how arrays work in system memory and why they start with a 0 as the first index. Okay. So let's say I want to declare a new variable events in C++. The syntax would be int, call it AR. Okay. So again, I have to type it. They're all going to be integers, AR. And then in brackets, I'm going to say what's the maximum length that you can have. Okay. You would think that C++ would take this opportunity to note how long the array is so we can track things, right? Not what it's doing at all. What it's doing is it's going to find a spot in memory. And let's say for simplicity that it's going to start at 1000. That's the memory address. Okay. It's going to reserve 5 consecutive blocks of 4 bytes each. So this one starts at 1000. This one's at 1004, 1008, 1012. This one starts at 1016. Okay. And would end at 1020. Okay. So we can store an int in any of those. Okay. So when we want to address these, this is going to be, so the AR, and here's the preview of pointers. An AR is a pointer to a memory location. That's what a pointer is. It points to some place in memory. AR in my example here points to 1000 as the memory space. Okay. If I want to get what is stored in the first integer sized chunk, I can say AR bracket 0. Okay. That means go to AR and don't add anything. Okay. But since we know what type we know it's an integer, and the system knows how much it takes to store an integer on that system. When we say AR1, what it's saying is go to 1000, AR's address, which is 1000, and add one of the unit length. An integer is 4, so this is going to take us to 1004. So AR1 goes here, and so forth. Okay. AR2, AR3, AR4 works, no problem. If we say AR5, okay, again, in Python, this would give us an index out of bounds error. C++ doesn't care. What's it going to return? Whatever happens to be in that memory. And not only can I return it, I can change it. So that's a problem. Okay. And we'll talk about some ways of dealing with that. But that's the basic idea. So an array or a pointer, sorry, back up, and I had it right the first time. An array is a pointer to some memory location. When we initialize an array, we have to tell it how big it's going to be, and it reserves that many contiguous, meaning all together, sequential spaces in somewhere in the system memory that the operating system's given for this process. Okay. And that means it won't be the same all the time. So every time you run the program, it'll be in a different location. But during the running of the program, it will be consistent. Okay. So it doesn't track how many items there are. It doesn't keep us from doing it out of bounds, any of that stuff. Okay. So that's the basics. And now we can look at some code here. Okay. And it'll take me a second here to switch things around. So again, the basic idea here is that we're going to be using this. Try to resize this a little bit. Hopefully, if you're on a smaller screen, it will help. We're going to be using this to simplify our code, because if we don't, it's going to get fairly ugly. Okay. And we saw this again if you were in Python when we're doing this. So the book gives an example if you're doing test scores. Okay. If we have 5 test scores, not a big deal. Okay. So if oh, have to send, if we have like 5 test scores, it would be easy enough to say, can't type today. Say test 1, int, test, or float, test 1, test, all that to 5. No big deal. We can add them together, get the average, not the end of the world. Okay. But if that goes to 100 test scores, okay, then it gets really ugly. Okay. So we don't want to be doing that. Okay. That would be a not good idea at all. There's an example program in the book, and it's ugly even for 5, but it gets really, really ugly as it goes further. Okay. So we're going when we're looking for cases where we can use an array. Okay, the first thing is that all the variables we want to clump together have to be of the same type. Okay, so if they're not the same data type, we can't put them in an array. We have to do something else. We'll talk about later other things we can do. Okay, and if they're the same kind of thing, it makes sense. Could we make an array of integers that are just randomly in our program? We could, but it doesn't make a lot of logical sense. Okay, so storing test scores would make sense. Storing stock values would make sense. Storing anything that's the same thing but multiple variations of it would make sense. You can have an array of strings. You can have an array of student names, whatever you want. Okay, so all that's okay. So then to declare an array, so the book defines an array as a collection of a fixed number of components, also called elements, all of the same data type, and in contiguous, that's adjacent memory space. Okay. We're starting with one-dimensional arrays. Okay. So that's all we're going to do in this chapter. And well, I think at the end of the chapter, we'll talk about multi-dimensional arrays. But for today, we're only going to talk about one-dimensional arrays. Okay. So when we declare an array, pretty straightforward. we're just going to say whatever the data type is, the array name, bracket, an int for number of elements. Okay. Now, of course, that's not legit. So I could say, for example, in our other example, int AR5. Okay. So once I've done that, and we can just say here, we can see out AR0, see what that is. It may default to 0. I'm not really sure. It used to not, but sometimes it does, sometimes it doesn't. And then we could go all the way legitimately up to AR4, but what if we do an AR5? Let's see what's there. Just printing it out shouldn't cause any problems, but it may be not correct. And this will also let us know if what it's going to default things to. It defaults to 0. That's fine. And it turns out there's a 0 in the next position, which is great, but there's no guarantee of that. Okay. I could put an AR, whatever number I want here. I could put in 115. And it's still, as long as it doesn't go out of memory, it's not going to give me an error. Just no guarantees as to what. See, this time it gave us a 32,766. What's that number? No idea. Okay. Now let's see. I don't know if doing the wall helps us here. It may. It is warning here to some degree, okay, that we haven't added any values to that, but it's not warning us at all when we go to the 115. So even the wall's not going to help us. Okay. So we're going to have to keep track of that ourselves. Okay. Which is somewhat unfortunate, but it is what it is. At least we know now. Okay. As far as adding items to our array, okay, so we can go back up in here. We can set things individually if we want. Okay, so I can say that AR sub 0 is equal to 15. I'd say AR sub 1 is equal to 34, whatever I want. Okay, and then if I do a 0 and a 1, that should print those out correctly. Okay, so there's no limitation on what you can put in those integers as long as they're integers. If you put something not an integer, you're going to get a type error. Okay. You can change these. They're totally mutable. Change them however you want, whenever you want, as long as they're valid values. Okay. So that's kind of how that's going to work. We can use this AR15 anywhere we could use an integer. Okay. So AR is an array. An array is a pointer to a memory location. Okay. AR bracket 0 bracket is an integer and it points to the number 15. Okay. So as we build more complicated things, it's important to realize that an individual element is like any other integer. So I could say here that AR1, let's do an AR2 here. AR2 can be equal to AR1 plus AR0. That's a weird order, I know, but you get the idea. Okay. Perfectly okay. So it's going to be 49 will be stored in AR2. And I can go ahead and print these out. So we can go ahead and make sure we're on the right path. Okay. So note that these are not persistent in that every time I get rid of the program stops and there's our 49. Every time that we quit running the program, we lose all of our values. So we're not storing them anywhere permanently in memory. Okay. So one thing that we can do that I think is helpful to us, this gets us to the idea of not having not going out of bounds and knowing that. Okay. And the easiest way to do that, we can set up here an integer, and I would do a constant. We're gonna do a constant integer. We could call it like array size is equal to 10, something like that. Okay. And then when we're initializing our array, we can use that array size in the initialization statement. Okay. And now, if we ever needed to, if someone is going through and you know we're wanting to check to see if they can add something to the list or to even to access it, we can put an if index equal is less than or equal to the array size, or it's between 0 and the array size -1. Okay. And you can use that to your advantage. So at least you know how big it is. Okay. And you can ask the user that information as well. Okay. So let's say we want to make a little bigger array to make it more interesting. So let's change this over to make it 100. And let's say we just want to put in the first 100 even numbers, starting with 0. Okay. So we could do something like this. We could do a for loop. We could say for int I equal 0. So again, the book doesn't do this, but I am. I'm going to declare I local scope only for this for loop. So it goes away as soon as the for loop dies. Okay. As long as I is strictly less than 100, so it goes up to 99. Okay. I plus plus. Okay. This is going to take me through the entire list. Okay. So with this AR sub I, square bracket I, then it's going to be the 0th element or the first element that has the index 0, second, third, all the way up to the 100th element, which has the index of 99. Okay. So right now they have no value, but I could set them equal to I times 2. Okay. So the first time through, it's going to say AR0 is equal to 0 times 2, which is 0. Then it's going to say AR1 is equal to 1 times 2, which is 2, and so forth. Okay. And I can initialize them that way. And then once I've done that, I can go ahead. In fact, I want to use here not 100, but array size in case that changes. Okay. So I can copy this. For the print, all that's the same, but I'm going to see out. And let's just put the number I. Actually, I want to put I plus 1 because we're dealing with the values, the index values, which are well, not the index values, the actual position values. I'm going to put a tab character in there. I'm going to put the item and indel. Okay. So typed all that correctly. We should be able, and you see, we've got all the way from the first element, which is 0, down to the 100th element, which is 198. Okay. So, and because I made the array size a variable in both my loop and when I initialized it, I can change this very quickly if I only want 50. Okay. And then I run this. And now you see I only have 50. Okay. So that's another advantage besides the fact that I can check to make sure I'm not out of bounds. Okay. But it makes it easy to go through the loops and I can change it whenever I want. Okay. So that's basically what we do, right? We're going to initialize the array. We often use a loop for that. Um, we can also, if you wanted, another way to do this, we could have the user input these, okay? And we could just say cn AR sub I. And you'd want something beforehand, like to enter up here, you would see out. Enter array data. Only. And change this to something like 10 so you don't make yourself crazy testing it. Got the wrong parentheses to start with, or wrong quote mark. Okay, then that should go through. see if that's good for us. Maybe ugly. So I can do one. Yeah, it's ugly. So it does work. You'd want to put something a little more pleasant there as far as the layout, but you can see it is going to give us, um, it is going to give us the correct result. Okay. So we can enter them, all that. We can do lots of stuff. We can sum them. We can do an average, all those things. Okay. So if we wanted to sum them, for example, I could just up here say int sum equal to 0. And then every time through, I would just say sum plus equal, and then ARI. Okay, that would calculate the sum in a relatively straightforward fashion. Okay. So other things that we can do, and we can just go that, figure this out here, see out, find my home keys. So change this back because that was pretty ugly. I've kept it at 10. So it's got the average there as being 90. That, oh, sum, not, no, say average is not 90. The sum is 90. That makes sense. Okay. And we can verify that, but I believe it to be true. The sum of the first 10 um, even integers. Okay. So we can also do something, we can figure out the largest element of the list. Okay. This is something that comes up pretty common. And I like to refer to this as the king of the hill algorithm. I'm not sure anyone else ever does, but I like to do that. So let's say it's the largest. Okay. And we can default here, the largest being our first value. Okay. So that's why it's the king of the hill. We're going to say item one with index 0, you're the biggest there is. And then one by one, we're going to check each of the subsequent elements to see if they're any bigger. Okay. So we've got largest equal to AR0. I can now start this at 1 because we've already set it equal to that. Everything else is the same. Okay. And I can do an if here. I can say if the current contender, ARI, if this is bigger than the largest, okay, then I'm going to set largest equal to ARI. Okay. If not, we don't do anything. And that should give us the largest value. And we have sequential, so the largest is the last one. So that's not going to do us. That's not going to be that exciting. But if you have an array that's of mixed, that's not sorted, that will make some more sense. Okay. So again, we don't have the automatic means to test to see if a call to an array, if the index is out of bounds or not. Okay. And if you want to do that yourself, then you would have to test that. Okay. So if I would do something like ask the user, see out which index item change. Okay. And I would have to have an in for choice, whatever. And then I could see in that choice. And I could put that in a while loop, testing to see if choice is greater. So I want the error conditions. If choice is less than 0 or Where'd my vertical bar go? There's my vertical bar. Different people. And choice is greater than or equal to our array size. Okay. If those are true, okay, either of those are true, then we would have to ask them again for our choice. Okay. So that's kind of the idea there. Okay. So something else that we can do when we're declaring our array right here, we can explicitly say how big it's going to be. Okay. Or not how big it's going to be. We can specifically put in the elements that we want. Okay. Let's get rid of all that. Okay. In fact, we wouldn't probably do that in this case. Okay. So when I'm doing my AR here, that's an integer, I can just say equals curly braces, whatever I want. 3, 6, 2, 45, 123, whatever. Okay. Just like that. So if you know exactly what your array is going to contain, you can do that. Okay. You could also, if you know if you know what it's going to be, you could also create your constant integer for array size, which would not be a bad idea at all. Okay. Um, but you can certainly do it that way. You don't have to tell it how big the array is going to be because you're telling it how many items to put there. Okay. So that would put at AR0 would be 3, and then all the way up to AR0, 1, 2, 3, 4. AR4 would be 123. Okay. Works just like everything else we've done so far. So you can certainly do that. Okay. Um, so one thing that you can't do, okay, you can't change the size of a list later. Okay. When it's declared, that's the only time you can change the size. Now, if you know only part of it, I could say something like int AR10 is equal to just the partial part. Okay. So this would put in the first 5 elements, and the rest would just be defaulted to 0. Usually. Can't count on that. Okay. But if you have a program that has an array, it's running along, and you hit the max element size, you can't just add one to it. It is what it is, which means that if you're writing a program, you have to determine the maximum you think you're going to need. Okay. Because you can't change it during the running of the program. Okay. Again, there are other data structures later that don't have that. Actually, probably not in this class, but in data structures. Okay. So some things that we can't do. Okay. So if I've got an int AR here and I've got another int, let's call it B, okay, which is also 10. I can't simply say B is equal to AR. Okay. That's going to give me an error. Okay. Let's see. I always like to do this live because they'll probably say, oh, there's on there. Yeah. Okay. We can't do an array assignment like that. Okay. So if you want to copy this, you would have to go through every item at a time. Okay. So I could, if I really needed to do that, I could go through A. Okay. So I could say for int I is equal to 0, I less than 10. I'm not using the array size on this one. I plus plus. Okay. I could then say here that B sub not 0 sub I is equal to AR sub I. Okay. And that would go through item by item, copy everyone over, and that would be fine. Okay. So the last thing we're going to talk about today is going to be sending an array as a parameter to a function. Okay. So let's say we're going to have a function. We're going to add its prototype up here. It's a void function. We're going to call it print array. Okay. And the print array is going to take the following parameters. Let's go ahead and do an int on array size. I mean, we can make that a global, but let's not. We're just going to call it array size right here. Okay. And we're going to do an int array like that. Okay. So we don't have to put in how many elements are there. We don't have to send the array size. We're doing that for our convenience. I could just send the array. Okay. But this allows me a way to check what's going on. Okay. Um, so one thing to remember here, we'll talk about the whys of that. Nope, that's all I need there. Um, every time we pass an array parameter to a function, remember an array is a pointer to a memory location. So we're sending, basically, it's the same as passing it by reference, which means any changes to the array during the execution of the loop or the function are reflected back in the calling program. Okay. So it's making changes. We're having side effects. Okay. Which may be what we want, it may not. So as far as why we do this, arrays can be very big in memory. Okay. And the designers of C++ have made the decision with something that could take up a lot of space in memory. If we didn't pass by reference, to pass by value, we would have to create another array in memory the exact size of the one that we're passing in and copy all those values over. Okay. So they just pass by reference by default. Okay. So, I mean, beyond that, there's nothing really special. So we could do that down here. We just have our void print array, which takes an int array size and a, just like that. Okay. And then down here, I can do my for int I equal to 0, I less than array size, plus, and then do cout. Do our I again if you wanted, put a tab, put a sub I, because that's what we're calling it here. L. Okay, that's all we're going to do. It's a void function. That's all it needs. Okay, that should be okay there. And then I could call this. So down here, I could just call print array. These are both of size 10. AR. Okay, and I could call print array 10B. That order may be a little weird. You may want to put the array first, but anyway. See if this works. Nope, I've blown something up. What have I blown up? Too many arguments. 2. And there are 2 there. Oh, that's because if you look, I've got a period there. That's interesting. Oh, up here. Yep, that's my problem. Doesn't like something. Oh, that in line 24, I've got a comma instead of a semicolon for my last one. Making all the greatest hits of typos today. Okay. So now if I run this, I get the first one and the last elements we didn't really do much with. Okay, down to here, and that's really ugly, but you get the idea. And this starts the second one, and they are the same because we made them the same. Okay. That shows that a couple of things are going on. Okay. So, one issue with that. Okay. So we now know that these are live changes that could be made. We're passing a live copy. Okay. So we can use the constant keyword to keep that from happening. Okay. So if we don't want the array to be changed, we would just put a const here. Okay. And then of course a const down here. And then if we tried to then if the program tried to change it, it would give us an error. Okay. And that works just the same, no difference. Okay. So in general, I mean, it's something I'm going to be looking for. If the function is not going to change any memory creation, which an array is the first one we've talked about, it should have a constant. Okay. If it's going to change it, that's fine. You don't have to put the constant, but the constant is now required. For me, it's not from the code. You can do whatever you want, but for this class, you have to put constant whenever the array that you're sending is not to be changed by the function. Okay. Simple enough to do. Okay. So I think that is all that I want to cover today. Oh, one more thing. There is one more. I'm looking through the book to make sure. A function can't return a value of the type array. Okay. So if you want a function to initialize, so let's look at this. So we want a function, we're going to call it a void. No, it's going to call it an int. We can't do that. Okay. So we're not even trying. You can't return an array type. So if we have a void called init array, okay, that's going to take, let's say, int for size, and then in this case, it doesn't want to be a constant. This we're going to call this int a bracket, whatever. Okay. Um, and then let's also have the value we want to initialize it to. So let's do an int value. Okay. So we're going to create an array of whatever size. Okay. The that's filled with all the same value. Okay. Take a look at that here to implement this. Okay, so I can do my for loop here. I can do for int I equal 0. I is less than size plus plus. And then at each iteration of that, the a sub I would be equal to value. And no return because it's a void. Okay. But to use this, then we would have to do something a little bit differently. We would have to already have an array to pass. Okay. So I would have to say something like int AR, let's say 10 again. Okay. Then I could say init array. It takes first the size, which is 10. The array is AR. And the value, let's say, to 99. Okay. And then we should be able to do print array, which again takes the size array. Okay. Okay. Just like something. Oh, it's called array. AR, not called array. Say what they're doing. Let's do it. Okay, we're good there. So when I run it now, we see that we have 99 in our array. Okay. So while I can't return an array as a type, I can send in the array by reference. And note that I can't put constant for it. So if I put constant here, that's not going to work, right? It's going to blow up. Okay. But that's the basic idea there. Okay. And we can often do that. Okay. So that's it for this section. Okay. The next video we'll talk about how to search through an array for an item and then how to sort an array, do some basics of sorting. Okay. So this is a complex topic, and we're really getting in to the most important part of C++, and that's the memory stuff. Okay. So this is our first taste of pointers, although the book doesn't call them pointers, but that's what they are. Okay. So it's important that you not only can reproduce the programs, but that you understand what's happening. Okay. So if you're at all shaky on the memory stuff, now's the time to get that straightened out. Okay. If you have any questions, let me know.